So for the next about half hour, we'll talk about ICS ranges and whether they're for your corporate office or for your home. We'll go over some points that I've learned and some things there. So Rob, next slide, please. So what is a range? I get that question quite often. Those of us that have been in the military or even played golf, we have bombing ranges, we have shooting ranges, we have, your golf club has a range. It's just a place to practice on. And, when we're talking about OT environments, it's best to practice, in a safe environment. Why do you need to use one? Well, it's really not a great thing to use a live production network for, you're testing out. Are ranges expensive and complicated to set up and maintain? They can be, and we will go through that here shortly. And what goes into these environments? I got a slide on that also. Next slide, Rob. So what is a range? Well, they're test environments. They're learning environments. They're proof of concept and technology environments to test on. They are always changing. You got a couple of pictures here of some ranges that were built. They come in all different shapes, sizes, colors, cost, and everything. We have one down in the lower left from the ICS Village. Those of you that have seen us at various conferences, such as RSA and DEF CON, and list goes on and on, places we go throughout the year, well, at least last year anyway. These ranges are built for a couple of different purposes. These are more fancy, we'll say. One, they draw people in with the lights and the stainless steel and the moving water and all that stuff. So people come up and say, "Hey, what is this? What am I looking at?" So we had the learning aspect there. The Lego City one up top there. I have to go back and look at how many Legos it took, but I believe it was like 60,000 Legos, which is pretty darn cool if you've ever seen that. If you've been to the Dragos office there in Hanover, we have that on display. I believe there's a YouTube video out on it also that we made. And then down below we have a pipeline range also. Now, the cool thing about all these, yes, they are flashy. They show well, but it's the control systems behind it that really make the difference. These are all built with real ICS hardware, whether it be distributed control systems or PLCs and HMIs and all kinds of things that are configured in a way that you would find them on a plant floor. But they're also configured and architected in a way that you can add and subtract things very easily for testing. For example, your proof of concept. So if your company is evaluating two different firewall technologies or SIMs or something like that, you really don't want to put them on your operating network. Put them in these test environments. Run some. Maybe you want to run some attacks against them, where run data that you would find out on your plant floor. Capture PCAP on the plant floor, run it through, or generate it with the hardware that you have. See what happens. Put malicious traffic through it, because, well, you can on your test range, because it's all going to be, in a safe environment, not connected to anything else. Should be all backed up and snapshots for the virtual nodes, so you can reset everything. These environments are also always changing. If you're not learning something, and if they're not changing, I think you're doing something wrong. There's always things to learn. There's always things to try. Next slide, Rob. What is in the range? Well, your production environment, your process control network, your cloud environments. These ranges are meant to do nefarious stuff against. You want to test things out. You want to see what happens if bad stuff gets on your network, whether maybe it's ransomware, or maybe you're a Dragos Intel customer, Worldview customer. Some TTVs out like or indicated, that's the stuff that you're going to do on your range. What isn't it? It's not a critical environment though. So they're made to crash. They're made to test everything out. Never do the stuff on a running live production network, or even a network that will, create a loss of revenue or loss of life or anything. So isolated networks, and then make sure everything's backed up. Make sure it's an environment you're not afraid to do stuff with. You get an email attachment that it's probably phishing. It's probably somebody sending you something bad, or asking for iTunes gift cards or something like that. Open that attachment up over in your test range. See what happens, because that test range is not connected to anything corporate wise or to cloud or anything like that. Next slide. Are ranges expensive to build and maintain? Well, it's kind of a loaded question. The assets that are in the range, I define an asset as any physical or device that will have an IP or some sort of address. For a DOI system, you might have everything at your house to set up. You might have an old desktop, or maybe you do have a high-powered laptop or some other kind of computer around that you can run a bunch of VMs in. So maybe the out-of-pocket cost is very low for a DOI setup. However, the ones that I showed on the second screen there, they are more complex. They can run well into the hundreds of thousands of dollars to build them. The manpower to put these together, it's not a small project by any means. I know I probably built at least a dozen in the last couple of years. The ones that I've been building, I try to cookie cutter them, but when they go into customization, there is hundreds of hours of work that needs to be done into them, whether it's configurations and seeing what protocols these devices talk to. If you have an RTU that talks one protocol, do you have anything to receive that? Just because it'll talk say DMP3, well, anything on the other end of that. If not, there's really no point in having an RTU on there. Talks DMP3. So not a small project at all. The maintenance of them, if everything's going right, the maintenance should be pretty low. But the one thing to stress most is take snapshots, take backups, all of that, because when you do open up that malicious email or that ransomware, or you want to launch some other sort of a crazy attack on your network, and things go things go bad, and you lock up your machines, you don't want to rebuild them from scratch. So have that snapshot to reverse everything that you've done. Keep some spare parts on hand. Fuses. When we start monkeying around with different IO and forcing things, and we can let the magic smoke out of the devices. So keep fuses on hand. Keep some spare parts on hand. For a DIY system, if you are using actual OT devices that you find on eBay or other kind of auctions, or maybe you're fortunate enough to buy some new stuff, quickly learn that, hey, this stuff's expensive. So it is hard to keep those spare parts on hand, but others are fairly easy to do. And generally, you want to build something that has the same type of assets found in your environment. So if you are a water plant, or if you work at a water plant, there's probably no need to have stuff that you find in mining, or stuff that you find in power generation or distribution. Yes, you might have some power stuff at your water plant, but focus on what you're on your core assets and what you're trying to achieve by it. There's a lot of talk around your PLCs and stuff like that on your network. The other thing to keep in mind is your virtualization. So are you gonna run everything in the cloud? Are you gonna run everything on the ESXi server, open box? So keep that keep the hardware in mind and the network switches, network infrastructure. So what goes in the range? A lot of different things here. This is only touching the surface here. From switches to firewalls, and both of those devices you're going to find internally to your network and also externally, because your infrastructure, your ESXi server and things like that, you need a way to communicate with that for a management purpose. You need a way to remote into that. When we talk about remoting into a range, do you want to have a console connection? If so, you're going to go to management console, say ESXi if you're using that, or do you want to RDP into a jump box? So now there are two different ways you're going to interact with your network, two different ways different traffic collection will happen and things of that nature. So keep that in mind. For example, the console connection with them, you're out of band. You're going into, say, an HMI. You're never really touching the network. Everything is done through that ESXi console. So what's going to happen is you're not going to show up on that network. So if you're collecting that traffic for say a proof of concept, or you running into some kind of SIM for testing purposes, your traffic will never show up in that. However, if you RDP that network, all that you're on that physical network or that virtual network, and that traffic will show up. Sensors, motors, controllers, field devices. I can't stress that enough, that you build you're taking all the time to build out your test environment, your range, for whatever reason, whether it's learning, whether it's a proof of concept, whether it's engineering reasons, to test code out, things like that. You really need the end devices. You need to see that motor turn, or that, in the case of the ICS Village ones that I built there, the level in the tanks go up and down. Having that cyber physical connection really makes a difference when you are showing people, or even watching it yourself. Very, very important thing to have there. It's also probably the hardest part for a lot of people. If you're not used to working with temperature transmitters and 4 to 20 signals, or heart signals, or motors, 3-phase motors and things like that, where do you start? It's hard enough to getting all of the we'll say IT stuff right. Your HMIs, your switches, your ESXi servers. But now we're going to go into the real OT stuff, which is your field devices. Ask people. ICS Village, we have a lot of these things. Drop us an email. Gladly help you out on selecting that stuff, or I'd say come to one of our events. But unfortunately, we're doing everything virtual now. Linux, Windows. We don't see a whole lot of Linux in OT. We do see some, and I shouldn't say Linux, I should say non-Windows. We do see some. So in your range, put in a Ubuntu box, because it's pretty straightforward and easy to set up. Or if you know things about Linux, install more of them. But we're definitely Windows heavy. Windows 7, Windows 10. I personally don't go anything lower than the 7. Yes, we still find it in OT environments. If you have them, that's great. But everything that I deploy is either Windows 7 or Windows 10 or comparable operating or server operating systems. Safety systems. The SIS systems, they do play a critical role in a lot of industries. I'd have to say that they are probably one of the more complicated things to find, to set up. And it's not that they are more complicated Programming wise or anything like that is just that there's fewer of them. We have PLCs that, a plant could have, dozens and dozens of PLCs through there, but they may only have one safety controller. So just by the numbers, they're less common. However, they are very important. We've seen some activity groups go against them or do nefarious actions against them. So if you have a safety system, if you get a hold of one, absolutely recommend putting it in. I/O devices, IEDs, HMIs, things like that, remote I/O. The more IP devices you can find to put on your network, I find it makes for a better environment. So use remote I/O when you can. Not only the onboard I/O from your PLC, but install some remote I/O blocks in there and generate more traffic. Next slide. So for home learning, another question that I get emailed a lot is, hey, I only have, $500. I really want to learn this stuff. What do I need to do? You can absolutely build something, for, a couple $100, or if, like I said before, if you have some stuff laying around, maybe you don't have to spend any kind of money. However, one of the things I want to stress is if you're building it on low to no budget at home, keep in mind that, the fundamentals that you will learn will be applicable over to an OT network. For example, Modbus and Ethernet IP and DNP3 and things like that. You will certainly see them in a live OT network, but they're not going to be the same when you're going to run them on a Raspberry Pi or in a virtual environment in your house. So the fundamentals are the same, but how everything's actually implemented and how they run everything may not be 100%, but you're still going to learn a lot of things from this. Again, the manpower. I personally think you probably have more manpower setting up a DIY system with no budget using stuff, open source stuff, than you would if you bought a PLC off of eBay or even from Gray Bars or another supplier. Only because now the stuff that you're gonna download, you have to fully configure where that PLC that you get. Yeah, you're gonna configure it, but there's already a lot done to it. So just be prepared for a lot of nights and weekends programming and figuring stuff out and hacking through things. For maintenance wise of them, it's the same thing as your other ranges there. Backups and snapshots, and keep the spare parts on hand. I see more open. You'd be using more open source stuff, and we're going to go through here the next slide or two some of the open source stuff I recommend. Certainly doable. Like I said before, though, just keep in mind you're going to find differences between your home setup and what you find on an OT network. Next slide. So for home, there are so many different things out on the internet. Google is your friend. These are a few things that I have used in the past, or I've seen used in the past. So we can just go through a couple of these things. So you're going to need a controller. You have soft PLCs. You have open PLC. Open PLC. If you just go ahead and Google that later, and you can download that. You can use that as a fully functional PLC, but it's open, and we're seeing more of that product being implemented in other in commercial products. Soft PLCs. There's certainly soft PLCs out on the market. I recently did a project where we deployed I think it's 25 of soft PLCs running on a Windows 10 box, and they look and feel programming wise everything as a physical PLC. You would never know it's a soft one though. You hit it with Nmap, but you're going to get Windows ports open. where that respond. But beside that, you program them the same way as you would a physical PLC. They have Modbus, they have Profinet, they have all your common protocols, and you really can't tell that they are not a hardware PLC. Protocols, I put 3 up here that are probably most common. They add OPC to that. There are hundreds of OT protocols out there. These 3 here are you can get them open source, you get them free. Again, if you Google them, bring them up, you go to the GitHub repository, you go to other places to download them, run them on your Raspberry Pi, run them in your VM, and they work just like a Modbus command from a PLC. Keep in mind though, it's not coming from a PLC. Your HMI is you need a way to have a visualization into the controllers that you're installing, whether it's a soft PLC or whether you put it on a Raspberry Pi, or maybe you're lucky enough to buy a couple PLCs from eBay or from your distributor. You need a visualization. I put VT SCADA Lite up there. That is a free version of a commercial product. We use that in the ICS Village and some other smaller projects that we've done. It's just limited by tag count. There's probably other HMI vendors out there that do the same. I just find VT SCADA Lite's pretty easy, straightforward to use. SCADA BR is a open source HMI. Supports Modbus protocol and OPC. For firewalls, pfSense. Again, you download that for free. The full featured firewall. It's not going to have your threat based blocking like a newer next gen firewall, but it certainly does the job. You can put them in your network, and maybe you want to go and set up your network, like the followed Purdue model, and you need Modbus to pass between level 1 and 2. You really don't need a next gen firewall for that. You're just going to open up port 502 inbound or outbound, and depending on how you're looking at it. You can get the fundamentals using a product like pfSense. For an IDS, Security Onion. A lot of people have probably already used Security Onion in the past, or is at least aware of it. Security Onion is getting easier to use. However, it does take some learning to get it up and running and getting it tuned the way you want to. But you're going to learn a lot of stuff about IDSs. Your hypervisor. We need a way to run these VMs. ESXi is free. You can go to VMware, download that. You won't have the connection into it with vCenter, but you can use a browser, or you can use a Fusion connection, or VMware Fusion, or VM Workstation or Player. All of them will connect into ESXi. VirtualBox, it's just an open source hypervisor like ESXi, where ESXi is free for the basic, but it's paid for if you get into certain configurations. Network emulators. Those have not seen the Navy Research Lab project called Core. Highly recommend looking at that. It's a pretty cool project using SDN that will go and emulate very large networks very quickly. Next slide. And that's it.